So we are still discussing renewable energies as an adaptation strategy, but in general, renewable energies, which are a big part of the climate mitigation so that we move away from fossil fuel energy and reduce the carbon intensity of energy, or maybe even decarbonize the energy system and so on. Are the renewable energy technologies ready for climate change? So this is a blurb about making renewable energy technologies ready for climate change. I'll just read it off. Since I'm summarizing the report, you get a briefer view. If you want, you can go back, read the entire report, because I skip many of the details that are very subjective choices on my part. Although this report explores, let me get the point up. Although this report explores the role of renewable energy projects in climate change adaptation, renewable energy projects are themselves impacted by climate change, obviously. For example, we mentioned the change in wind speeds, and investing in wind energy has to account for how this may change with time at a particular location. Project developers must thus increasingly adapt risk mitigation strategies against extreme weather conditions to ensure that the renewable energy projects are resilient to climate change and suitable for deployment under harsh conditions. So this is talking about shorter-term extreme events damaging renewable energy systems and grids maybe, but the example I mentioned of winds changing is more of a longer-term risk information. The upcoming IRENA report, Strategies to Mitigate the Impact of Extreme Weather Events on Renewable Systems, addresses this issue from the perspective of project developers and policymakers. I will try to have a few podcasts on that separately. In particular, it provides best practices on how to mitigate against extreme weather conditions based on comprehensive case studies. So this is always about case studies. Very few blueprints exist that can transfer the solutions everywhere. Here, some of the best practices for project developers are summarized in a 3-step process that encompasses the assessment of extreme weather conditions at the renewable energy project site. So region-specific local information is very critical, especially the projections which are reliable in many ways. Let's say for temperatures at a certain large scale are not reliable for precipitation even at a large scale, but when you go to small scale, everything becomes uncertain. So how do we account for this uncertainty? Okay, the second one, the assessment of the risks associated with these extreme weather conditions and the type of renewable energy project, and the development of a risk mitigation strategy. These are the 3 steps. So step 1, we are briefly looking at these, so we'll read them off. Assessment of extreme weather conditions. Project developers must determine the application of extreme weather conditions for the renewable energy project. The report identifies 8 clusters of extreme weather conditions that are relevant for renewable energy projects, including 4 short-term weather events like tropical cyclones, mid and high latitude cyclones, severe thunderstorms, and tornadoes. Tornadoes is more specific for some parts of the US nonetheless. And 4 long-term climatic conditions like cold climates, desertic conditions, coastal conditions, and high altitude conditions. By examining macro factors such as the climatic environment and micro factors such as local environments, project developers can establish a basis for risk assessment for the renewable energy deployment. In step 2, assessment of associated risks is important. I won't read all of these, but it involves financial risks that must encompass additional investments for dealing with these associated risks. And you also have to, of course, be prepared for loss in revenues like downtime, degradation, premature decommissioning, maybe because the winds died away or the climate changed in a way that your solar energy farm is not viable economically anymore, and so on. Thirdly, development of a mitigation strategy. Project developers can choose from a wide range of mitigation measures. In particular, they must make trade-offs between different measures across various renewable energy project phases. Project developers can either make upfront make an upfront investment in the quality of the renewable energy core components, the mounting structure and installation service. Secondly, insure against certain unpreventable impacts or unexpected risks. Bear certain risks by taking measures during the operation phase if a renewable energy project has incurred damage from an extreme weather event. Okay. The best mitigation measure is highly dependent on the type of damage and the type of renewable energy technology and the local environmental conditions and the accessibility of high quality components and experienced contractors in the local energy ecosystem. Again, very local region specific technology expertise, and whether expertise or technology transfers happen or not determine how the entire humanity will move forward on adaptation in general and mitigation as well. So let's read a table here on renewable energy solutions for adaptation in the ocean, coasts and small islands. Wind is picking up, window is open, so I'll watch out for how bad the wind noise becomes. Again, we are looking at climate impacts like water scarcity caused by sea level rise, migration, displacement and relocation caused by sea level rise, reduction in food production from agriculture and aquaculture, deterioration of local natural resources as well along coasts and especially for small islands. It's the small alliance of small island states that asked the IPCC to come up with impact assessment and scenarios of 1.5 degrees C as a global warming target instead of the 2 degrees C that was agreed upon in the Paris Agreement. Okay, I've discussed these details elsewhere, you can look up. What are the adaptation needs? They are like stable freshwater supply needs, water quality enhancement, we have discussed these but worth repeating them, defensive measures against sea level rise, food security enhancement, environment friendly tourism as a main income source. So many of the island states, coasts, beaches, oceans have tourism as a big part of their economies, and one has to start including specifically the reduction of tourism footprint on the environment as a part of the mitigation. In this context, as renewable energy solutions. Energy related measures then will include desalination, water purification, generation and distribution of electricity in emergency settlements. People go to Puerto Rico, get hit by a cyclone, flights get a hurricane, flights get cancelled, they have to stay for a while, power gets knocked out, and so on and so forth. Fuel supply for agriculture and aquaculture, and fuel supply for tourism. What are the renewable energy solutions? Renewable energy based seawater desalination, solar pumps, solar water purifiers, and energy and non-energy services could be coastal or tidal barrage coupled with wave tidal power generation, horticulture with renewable energy for migration, displacement, etc., hydrothermal cooling. Non-energy services include fisheries and aquaculture in offshore wind farms, which we discussed before in another context, marine protection areas around offshore wind farms, which also we mentioned, renewable energy based ecotourism, solar, wind, hydrothermal cooling, etc. They sound a little broad, but each one is important, and especially in terms of synergizing renewable energies for mitigation and energy and non-energy services in the adaptation sector from the renewables as well. Let's read one more before we move to box 3. Renewable energy solutions for adaptation in the human health sector, which is very critical. Climate impacts: increase in heat waves, loss of labor productivity, increase in disease and fatality, especially in vulnerable groups. People who live in non-solid structures, in slums, low incomes, low water access, energy access, etc., become very vulnerable. Adaptation needs include adequately maintained temperature, ice and cool drink supply, emergency health service, enhanced healthcare service. I have an entire course on climate and health where we discuss some of these issues. I have an entire series of podcasts or a course on subseasonal to seasonal forecast applications, which is also applied to health sector, so you can look at some of the details there as well. Here we are specifically talking about renewable energy solutions for adaptation in the human health sector. Energy related measures include indoor and outdoor space cooling systems, freezing and chilling, ventilators, energy service for healthcare facilities, etc. Renewable energy solutions, renewable energy based active cooling systems. Non-energy services include solar blinds to provide passive cooling through shading. Sounds fancy, but this could be very simple to implement and very helpful to reduce many degrees of heat. Enhanced medical service by renewable energy. Okay, the continued discussion on climate impacts, impact of high temperature on healthcare system, indirect human health impact from water sectors, so perturbations to the climate risks or climate impacts on the health on the water sector obviously always leads to health impacts as well. Indirect impacts, again, human health impact from the food sector, so climate affects the food sector, nutrition security, food security affect the health. Climate resilient, so in terms of adaptation needs, climate resilient health system is needed, water quality control, water treatment and recycling, food system stability and utilization enhancement, and in terms of energy related measures, health cold chain system, so vaccine samples, etc. This could work well with local energy production that we talked about before. Water sanitation and purification, wastewater sewage and sludge treatment, greenhouse fuel supply, cooking fuel supply. Okay. What are the renewable energy solutions? Renewable energy based cold chain system, renewable energy power supply, of course, renewable energy based water purification and sanitation. This shows up in many aspects, but very important for health as well. Small scale water purification through renewable energy could be very critical life-saving system. Renewable energy based greenhouse horticulture and vertical farming, and clean cooking stoves. These are already many efforts from NGOs and so on in various places that happen in this sector. Okay, so we'll come back and look at renewable energy for health service in the next podcast. So we'll keep plowing through this IRENA report, and then I will look for that IRENA report on protecting renewable energy systems under against extreme weather events. Okay, we'll see you in the next podcast.